Now that we've covered why it is extremely painful to try to take the integral of this guy down here using a trig substitution, let's talk about how we can give ourselves that hint we got last time. In other words, how can we break this apart into some simpler fractions that will make the integration comparatively easy? So this process of partial fraction decomposition has 4 steps to it, and once we get going with it, it's actually not that complicated. So the very first thing we're supposed to do is actually something we've already covered in section 8.1. If the degree is bigger on top than the bottom, go ahead and do long division first. It might make your job easier. Second, go ahead and factor the bottom of that fraction. Right, like in our case, we've got 1 over x squared minus 5x plus 6. We can definitely factor the bottom there. Third, for each of the linear factors that we see on the bottom, we're going to write some terms that look like a number over that linear factor. Now, it gets a little more complicated if that factor shows up more than once. So for example, if the bottom factored is x minus 2 times x minus 2, I could write that as x minus 2 squared. Then not only would I need a term that looks like a over x minus 2, I would need another term that looks like b over x minus 2 squared. Okay, so if a factor shows up more than once, you might need multiple terms showing up to account for all the different ways that factor could show up. And then finally, we'll actually get to this a little bit later, quadratic factors have to be treated a little bit differently. So right now, we're just going to focus on steps 1 through 3. We'll hold off on step 4 till we get a little more comfortable with this process. So remember, this integral would have been much easier to do if I knew how to factor this guy, or break it apart into 2 nice fractions. So let's try to follow the steps. First, should I divide this? Well, no, it's not an improper fraction. The degree is really smaller on the top than the bottom, so I don't have to do anything in step 1. Step 2, I need to go ahead and factor the bottom. So let's see, I'm looking for numbers that multiply to 6 and add to negative 5. That's going to be x minus 3 and x minus 2. Okay, so I've made some progress. Now, in step 3, I'm supposed to take each of those linear factors on the bottom, meaning the stuff that doesn't involve an x squared, and I'm supposed to rewrite this. So here's what I've got right now, as a over that first factor, and then they're using a1 through am. Let's just use the letters of the alphabet. B over x minus 2. None of these factors is squared, so I don't have to worry about like a squared term or anything. Eventually, it's going to break apart to look something like this if I can just figure out what a and b are going to be. Now at this point, I'm ready to just do straight up math. I don't need steps to tell me how to do the rest of this. I'm just going to find the values of a and b that make this equation true. So let's combine the right side of this equation, getting a common denominator. So I'm going to multiply this first fraction by x minus 2 over x minus 2. I'm going to multiply this second fraction by x minus 3 over x minus 3. So let's see, I've got ax minus 2a plus bx minus 3b all over x minus 3 times x minus 2. Okay, so apparently both sides of this thing are supposed to be equal. I just need to find the values of a and b that make it true. At this point, we're going to take all the information we have in the top of our fraction and just turn it into a system of equations. So let's start by looking at the x terms on the top. If I look at the right side, my x terms are ax and bx. Okay, so I could write a plus b. That's the coefficient of my x terms. Now let's look on the left side. What's the coefficient of my x terms? Oh, it's 0. So by looking at the x terms, a plus b is apparently equal to 0. By looking at the constant terms, on the right side, the constant terms I have are negative 2a and negative 3b. If I look on the left side, the constant term I have is 1. So if I can solve this system of equations, then I've found the values of a and b that make this work. Okay, well, systems of equations, we've learned a variety of ways to solve them. You can do it by hand, you can do it on the calculator and using matrices. If you're doing it by hand, you can do substitution, you can do elimination, you can do Gaussian elimination. We have tons of options for how to solve systems of equations. So I'll just take the easiest option that seems apparent to me. I'm going to use linear combination, or you could call it elimination. So I'm going to do 2 times the first row plus the second row. If I add all that up, 2a minus 2a is 0. 2b minus 3b is negative b. 2 times 0 plus 1 is 1. And so, if I solve this, I get b equals -1. So, now let's go back to one of these equations and plug that in. I'll try the first one. A plus b equals 0. Well, hold on. B is -1. So a minus 1 equals 0. That means a equals 1. So finally, going back to what I had originally written, instead of just writing a over x minus 3 plus b over x minus 2, a is 1, and b is -1. So that's it. That's how I find a partial fraction decomposition. So again, just to summarize, I divided if it's improper. Didn't apply here. I factored the bottom. And then for each of those factors that shows up on the bottom, we're just going to put some letter over that factor. Okay, and that's it. Once we solved it out, we were able to find that a was 1, b was -1, and there is our partial fraction decomposition, which makes our integral much easier to do.